Okay, guys, this is the last video before break. We talked a little about trigonometry, and basically, here's the beginning of the end for you guys. We're going to get into the unit circle, but to get into the unit circle, we're going to start talking about all the fun stuff that you've already done in your math classes. We're going to start talking about SOHCAHTOA. SOHCAHTOA, sine, cosine, tangent. There they are. Sine, cosine, tangent. And then we're going to add to it. We're going to add to it cosecant, secant, and cotangent. Why? Because these are the inverses of those things. And we need to know these things. And we use these things when we're talking about trigonometry. We're talking about the unit circle itself. We can find all these wonderful ratios that existed there. And you were taught some of these things when you were working in your algebra classes or your geometry classes. You looked a lot at, right triangles. And when you looked at right triangles, you sort of, hey, that's right, we had that slanty side, which was the hypotenuse. We had the opposite side, which is the opposite from the angle. And, you always saw that weird O with a line through it. And your teacher said, hey, that's theta. And you were like, that doesn't look anything like a theta. And in reality, it really is a theta. Greek letter. I don't know what theta is, you said, and you just went with it. So what it does is it tells you where the angle of reference is, where your reference point is. So if you're looking here at theta, you know that the side across from it is the opposite side. There it is, the opposite side. And then the side right next to it, that's the adjacent side. Very simple idea. And how do we use those things in a sentence? No. How do we use those things when we're talking about the functions? Well, if you look over here, it says the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And, of course, the tangent is the opposite over the adjacent. And then we come down here, and we see the cosecant is just the inverse, or the reciprocal of the sine. So instead of opposite over hypotenuse, it's hypotenuse over opposite, etc., etc. And those are those 6 functions. And you'll be able to write those 6 functions as long as you can find the side lengths, right? And there are some challenges to finding those side lengths, and you need some tricks in your bag, right? So you need tools in your toolkit. You need tricks in your bag of tricks. Here we go. I'm going to teach you a couple of tricks. First things first. You're going to be given 2 sides and an angle. And you say, well, what do I need? It's just a theta. It's not an actual angle. Well, you're going to say to yourself, hey, theta, Mr. Sokol says theta is just that reference point where we're looking from. So we know that over here, this side here is the opposite side. This side here is the adjacent side. And I'm looking for the hypotenuse, right? I'm looking for the hypotenuse. Well, we know when we're looking for side lengths, 2 sides, the 2 legs of the right triangle, right? When you square them and add them together, are going to be equal to the square of the hypotenuse. That's what Pythagoras said. Pythagoras created this theorem that worked for every right triangle. So let's use it. Oh, Mr. Sokol, I can't believe you're pulling this old dog out. A squared plus B squared equals C squared. Gosh, I learned that years ago, Mr. Sokol. You mean I finally get to use it? I haven't used this in years. Let me dust this bad boy off. And here we go. We're going to dust this off. Now, when you used it before, you came up with numbers that were like super simple to work with. This one's not going to be so easy. Ha ha ha. Here we go. We're going to say 10 squared because that's a 10 right there. And this is a 5. 10 squared plus 5 squared equals C squared. This is going to be C for us. All right, 100 plus 25 equals C squared. Well, I'll take the square root of both sides. So the square root of 125 equals C. Wait a minute. 125, that's not a perfect square. Oh, well. We can break this up into 25 times 5, which would then be 5. I'm going to do 5 times 25 in the square root symbol, which then simplify this, we can take the square root of this 25, put the 5 outside, we'd have 5 root 5 is our answer to C. So this side length is 5 root 5. And so now we have everything we need, right? We have our sine. The sine of theta equals 10 over 5 root 5. Cosine equals 5 over 5 root 5. And tangent equals 10 over 5. All right, and the others are the reciprocals. There's some simplification that can be done. I hope you understand that 10 divided by 5 is 2 over 1. You can get rid of that 1. We don't like to have a square root in our denominator, so please use the idea of rational equations, of simplifying radicals that you learned very early on during the year. Let's get rid of that radical denominator. If you can do it, do it. If not, I'll put another video on to show you how to do it. I don't want to go back, and I don't want to spend a million years. Suffice it to say, when I simplify the sine, I'm going to just keep writing down here. When I simplify this, this is 2 root 5 over 5. Okay, and that's the sine of theta. Cosine of theta is root 5 over 5. And tan theta is still 10 over 5 or 2 over 1. Other than that, we should be good to go. We'll move on and we'll talk about this. Let's go ahead and use this guy right here. Well, what do we know of as the secant? Well, the secant is the reciprocal of cosine, okay? And so if I know that secant is the reciprocal of cosine, I know that this is the hypotenuse over the adjacent side. Okay, so I'm going to draw myself a triangle. Draw myself a right triangle. It doesn't have to be perfect. I know that this is it. I know that this is 8. And I'm going to say this is theta. Just for fun, I'm going to say this is 5. Okay? And if this turns out to be bigger and it doesn't look bigger, it's just my using this as reference. Because you're not going to use this in your answer. You're just going to rewrite all of these things, right? You're going to use the given trigonometric function to find the acute angle. We'll get to that. Okay? I want to find the 5 remaining trigonometric function values of theta. So I need to know what this other side is. Yes, I know what cosine is right away. There it is. Cosine theta is 5 over 8. Woohoo! I know parts of my other values because I know that this is the hypotenuse and I know that this is the adjacent angle. That's really wonderful, but I want to know what that opposite side is. I need to know what that is. So let's use the Pythagorean theorem again, but we're going to use it a little differently. We're going to say that a squared equals, or we're going to say that a is equal to the square root of c squared minus b squared. Oh my gosh. We've just rearranged this Pythagorean theorem and now we're doing some work with it. Here it is. C squared, 64, minus 5 squared, 25. What's 64 minus 25? Why, that would be 39, right? I hope that's right. Looks right to me. There we go. Well, a is equal to the square root of 39. 39, sir. Not divisible by 9. Not divisible by 6 because there's no 3 and 2. I don't see any perfect squares in there. We're stuck. I don't see any 16s. You see any 16s in there? No? Anyway, let's call it the square root of 39. Woohoo! This is what's different about using the trigonometric values now as opposed to when you used them in geometry, as opposed to when you started using them in algebra, if you ever got that far. Using these trigonometric ratios in a big time class, in a big boy class like Algebra 2, well, we end up with square roots. 39, yuck, over 8, which means that the cosecant, oh, this is even worse. Look at this. It's 8 over the square root of 39, but we can't do it that way, so we have to make it 8 root 39 over 39. It's garbage. We hate that. What a horrible thing to look at. But that's the way it goes. All right, and then we know the tangent would be opposite over adjacent. So tan of theta is equal to root 39 over 5. And cotangent, here we go again. Cotangent of theta is equal to 5 over root 39. Oh, yucky. Which simplifies to 5 root 39 over 39. Yucky. Yucky, 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 yucky. There it is. Those are they. We can move on to the second side now. Not a very pretty sight sometimes, right? And the only thing you're going to talk about on this other side is filling in the rest of the triangle. You know all your trigonometric functions. Now we're just going to finish up the triangle, right? The best part, the super easiest part, is filling in that extra angle if you're given one of the angles, right? We all know it has to equal 180. We all know it's a right angle. We all know that all right triangles have a 90 degree there, so we know that these two things have to equal 90, right? So we know that this is 65 over here. We know if that's 25, this is 65. So I've already taken care of that. We know this is 30. Now I know on this page it says you don't need to do that. What we need to do in this section, I'm just giving you ideas because you're going to have to do it down here. What you need to do is solve for x in this one. Well, x in this case is the opposite side. We're looking for opposite. And what we could do is say that the sine, because we're given the hypotenuse and we're looking for opposite, the sine of 60 degrees is going to be equal to x, or what we're looking for, the opposite, over 20. That's what the ratio would be. Now, unfortunately, I need to solve for x, so I need to multiply both sides by 20. This is very much like physics. If you'd like me to give you a physics example that relates to this, I'll do it momentarily. Say, for instance, this is 20 meters a second. There you go. Physics example. This has been launched in the air, right? This has been launched at a 60 degree angle at 20 meters a second, maybe 200 meters a second. I don't know. But it's been launched at 60 degrees. And I want to find the vertical velocity of that object. You guys who are taking physics right now, there it is. There's your example. You always question me on how math applies to what you're doing. Here it is. So here's how you solve those problems. The magnitude of that vector, of that firing off at an angle, times the sine of 60 gives me that answer. And unfortunately, I don't have my calculator out, So I'm buying time by continuing to talk. And I'm checking to make sure I'm in degree mode. I am. So I'm going to say 20 sine 60. And I'm going to say 17.3. 17 3/10, right? Round to the nearest tenth is what it says. All right? That's how you solve for that one. If you were given two sides, you could go backward. Let's see if I can find two sides and find an angle. Here we go, right down here. Excellent. If I need to know an angle and I only know two of the sides, let's use an inverse trigonometric function. Let's find this angle right here. The way I can keep using sine. You know what? Forget it. Let's find this angle down here. Let's find angle R. We haven't used cosine yet today, right? Let's go ahead and use the cosine function. We already did this. Let's get it out of the way. Here we go. What this says is that cosine of R, nothing there yet, is equal to the adjacent side divided by the hypotenuse. There you go. We have 3 and we have a 10. So we go ahead and solve this for R. Well, I'm going to divide by the cosine. Well, when we divide by a fraction, we multiply by its reciprocal. So wait a minute. 1 over cosine. Hey. If we take the inverse cosine, oh, there you go, times that same ratio, right? We put that into the calculator. That's going to give us the angle. So if you know the two side lengths, you find that function. You use the inverse of that function, which means you punch the button second, cos, and then 3 divided by 1, 0, and enter. There you go. Those are the keystrokes in the calculator. Here, I'll show you. Just kidding. Second, cosine 3 divided by 10. There it is, 72.5 degrees. This is 72.5 degrees. If this is 72.5 degrees, this has to be 17.5 degrees. Right? So now I'm done with all these angles. The only thing I have left is this wonderful R. The side R, the side across from this. I could use trigonometric functions to find it, or I could just use the Pythagorean theorem. I think I'm going to go with the latter. I think I'm going to go with Pythagorean theorem. And it turns out to be the square root of 91. Really? That's what these textbook creators want you to find. The square root of 91. Silly. Anyway, that's how you do it. Congratulations. Now you can complete your homework.